Hello, everybody. Welcome to the second live stream of creating a programming language. Once again, my dogs will be annoying and loud and everything in between. What's going to be a little bit different, I actually wrote a code of conduct which isn't long, and if I can find it on my phone, because I don't have Chrome pulled up, because I didn't want to waste the computing power. Actually, can I check on my phone? Let's see what happens. Yeah, probably not. Can I just go to my Can I just go to my me? Can I just go to who I am? Info. Here we go. Okay, here's the updated code of conduct. Essentially, unless you're trying to fix a bug, I will ignore backseat programming. I got too heated last time, and that I don't want to do that again. So if you don't like how I'm coding something, you can chat, you can tell me, and I won't respond to you. Unless something is like actually wrong and the compiler's going to break or it's not going to do what I want it to do. Then I will probably ignore whatever you're telling me. But, here we go. Let's try to have a good time. If you have any questions, please ask. I will be more than happy to answer them. How can I? Okay, I guess I just have to type it out. Work. Cool. All right. Well, let's get into it. I think I pushed all of the code to GitHub. I can check. We will see. Oh. Yes, okay. Everything has been pushed. Can I make it pretty? What does that look like? Doesn't? Okay. Okay, everything is on GitHub. I'll put that somewhere. No. I don't know if I should wait or not. Probably not. I probably shouldn't. I probably just start. The people, y'all can catch up. After probably 30 minutes, there will actually be somebody watching. So I'll just go ahead and start. I'll do some of the, I was going to do some cleanup. I'm not going to do some cleanup until after a certain part, but I am going to switch the tokens. We're heap allocating all of them, which eventually is going to be a problem. We don't really want to do that. It's expensive to do it every time, and we don't need to because it's not really carrying a whole lot of information. If we look at our token structure, it's really small, and there's no reason for us to heap allocate it every time. And so we're going to tackle this to-do here. Can I probably only... I don't know how this plugin works. I think it just highlights it. I'm going to think if I could just... do this. Okay, so there's a little bit of to do. We'll do those, I think, first, and then we can see if there's more cleanup. And then we will go from there. And by the end of the stream tonight, we will be running our code because we compiled our code last time, which I may as well demo right now. So we have our test file here. It pushes the number 30 and the number 12 onto the stack. Our add instruction will pop those off the stack, add them, and push the result back onto the stack. Halt will pop the last value that's on the stack and return it. At least that is what it will do. It doesn't do this yet, but that's kind of the idea. So when we run it, we should see 42. That we'll see 42 somewhere, and that will be important. We can compile our code that we have here. And right now it just has a simple output file. We can't look at it because it's binary. And so if we look at it like this, we will see one, if we come over to our bytecode file and we sort of compare these, we can see that this one here is our push. We'll push the number, and then we have, it's a 4-byte number. It's 32-bit number. 1E is just hex for it's just hex for 30. Thank you, Venus2828. I love you too. Then we have another push here, and then 12, and then we have our add instruction and our halt instruction. Thank you for going out of your way to create an account just to say that and making it so stupid. So I don't know what it wants, but I'm going to give it what it wants. Or I don't know why it wants it. I know what it wants. So we need to find a way of taking care of this. Now, because we can pass things by value, we can, and there's not a whole lot of values here. It'll be okay. So we're going to do, oh man. We can't really return that, so we're just gonna void. And we'll put it here. I think. And then we really won't need this. Well, we'll leave that because we'll need to, I want to change the token structure a little bit because, and take from Reese's thing that he said last stream and probably do a union on the data here so that we can have a couple of different, sort of data types in there. Instead of having to do what I've done in the past, which is to kind of have this be like a pointer to data, we can union that and make that a little bit easier. Well, wrestle a little bit here, but make it easier for us in the long run. Thank you, Venus2828, for the follow. Appreciate my fans. Okay, so I think we can, yeah, that's going to be the best way, because we can't really return the structure, I don't think. So we kind of just have to do this. So we'll do that, which means we have to change this up a little bit. And that's basically it. Don't do that though, and we'll just leave this. This won't do anything right now. And so I guess here. Oh goodness, my brain already hurts. Just trying to think about this. Because I'm gonna end up doing a memory oopsie at a certain point. So we have to come in here and we gotta change that. I think we can do it like this. Okay, well, I guess before I do all of this, let me go back to the parser and sort of figure out like what would be the best way of doing this. So I guess if we have a number, we parse the number here, and then we'll get our number back. And then I don't know, because I want to do this in like as little lines as possible, because I mean, okay, so let's say that we have a token. Let's just say that we have a token here, and we need to do something with this token. We can create the token as such with our number and our line. We can do that. And then just throw the token in there, I guess. Right, and then copy it. We're copying it here. We're just copying like the values, and then it doesn't matter like where this is anymore. We can copy it. I think that's probably the best way to go, is to have this up here and then do that. So that's fine. That works. And then we'll have a pointer to a bunch of different tokens, and this will still grow the way that we had it growing before. We just won't be heap allocating tokens any longer, because that's stupid. I don't know why I ever thought that would be a good idea. Okay, so what are we going to do now? I like this, but we got to go and change a bunch of stuff. So let's figure that out. This is fine. That does what we want it to do. This is fine. That does what we want it to do. Here, we got to do that a little bit differently. We got to knock that down one. But that's fine. That's all good. It's all good. We got to knock this down too. We're doing that by whatever. Okay, so now we'll take... Can I do it like this? The type of token. Oh, wait, no, and then I can do that, right? Right? Okay. And then I can do token. Oh, well, that's dumb. Okay. This is bad practice. But let's remember the code of conduct. So we'll just do it like this then. Or because we already did this, we can just pass that. We can just do it like this. Right? I know I'm not explaining this very well. I will very briefly. We can return this because it's not going to matter. Again, I'm not explaining, but I will. Give me one more moment. Let me change this really quick. Okay. I don't think, actually, you know what? I'm going to go ahead and Whoa, that was not the thing I wanted to do. Okay. I'm going to go ahead and return this by pointer / reference because maybe we'll want to do that. Maybe we'll want to change it. And if we want to change it, then we'll need to do that. But okay. So here, we're just taking the reference to just a place in this list that we have here, in this list of data that we have. And here we are passing in this token, which is just a pointer to somewhere in here. And we are giving it we're copying all the information from this token up here that we passed into the add. And we are, in this function, we are assigning everything to this place in memory. I think this will work a lot better because we are still, through all of this, we are not heap allocating anything. The only thing that we are heap allocating is the list itself, which we can just copy the values into, no problem. While this probably, at least currently, doesn't have major speed implications, it definitely still has memory implications, especially down the line where we don't want to be heap allocating everything. That's really, it does have speed implications, and it has memory implications as well, which are they kind of hold hands, but that will ultimately be better. And here we're going to do the same thing. We will token create, and we will pass in the token, and we will pass in instruction. We will pass in the actual instruction and the line. And here we will just give it the token. Right? We just give it that. I mean, really at this point, no, it's probably good to, I'm gonna say, I mean, at this point we could just take these values and plug them in here, but I think for the sake of everything looking nice and working, okay, let's test it. I'm sure there's an issue somewhere. Yeah, here we go. In function token list destroy, which is not in here. It is in here. Hello, sir. How are you? You made a logo. I don't know what that means. Why can't I free that? Because it's not freeable? I mean, at the very least, I should be calling token destroy here, which we will probably need later. Except that's not pointer, it's the data at I. So that's better. We actually do need to free this. It's a staple. One second. Let me look on my app. I don't, because I use Restream. I think I've said this before. But maybe it's not showing me correctly? I'm not sure. Let me briefly look at the, okay, so the chat is definitely not gonna show for me. Can we just take a second to talk about the fact that I have 69 views right now? That's insane. 69 total views. Appreciate that. Okay, I can't see the staple, sadly. I don't know what the character I'm getting in the, here, I can show you. The character I'm getting is weird, and I don't know if that's correct or not, but Unless that's actually just a staple. Because if that is literally just a staple, I like it. I could just be really dumb. Okay. This should be fine. We're going to try it again. I don't know why it did. Oh yeah, because it's not a pointer type. Okay. Yeah, briefly, let's just compile this and see if it works. If it doesn't work, then we know it broke, but my guess is that it's probably working. There's no reason for it not to work. So yeah, this looks like it's exactly the same as it was before, which is nice. Okay, so we switched it over. Okay, cool. So tokens are now stack allocated and not heap allocated, as far as I'm aware. I guess they're momentarily stack allocated and then moved into heap memory, which is infinitely better. Way better. Thank you, the Shadow Skill, for following me on Twitch. I've also made it a rule that I'm going to announce every follower in my terrible R-rated trailer voice. Or announcer voice, gaming announcer voice for all my Twitch followers. Of which a surprising amount is occurring. Okay, so I'm going to commit that because that's important. Also, I figured out I don't think that the thing that's showing on my screen actually gives anything away about my GPG key, because that's what it's doing when it pops up and enter your password. That's what it's doing. I don't think that that's sensitive information that it's showing. I think it's showing a public part of that key. I really don't know, but we're gonna find out. Or I should research it, but who does that? Oh, crap. What? Is this the fifth one? I have terrible... Yeah. I have really terrible Git practice as well. Where, that's the main thing that shows up, and then, later I say what it did. So, tokens are no longer heap... Or tokens themselves, I guess. Themselves are no longer heap allocated. Yeah, this thing, I don't think that this is actually bad. It could be. I'll look it up. And I'll just go ahead and push that. What did I want? Okay, I think at the end of the stream I will find a good way of displaying my GitHub link to this. It's github.com/JonahIsADev is the same as everything else. /staple-VM. It's pretty easy. Or you can just go to my repositories. It's the first one. Yeah, so okay, so we're gonna keep trucking along. We got some more to-dos. I forget to okay. Nice. Okay, there's a couple more things we got to do in here that we don't need to do yet, so I'm not going to. I lied. We're not doing any more cleanup. We're done with the cleanup. Cleanup sucks. Next, what we're going to do, I'm trying to think of what my plan was, because I had a plan in my head and it's gone. So we're just going to move straight into the runtime, I think, because I think that's kind of the goal right now. Yeah. So let's go. Let's just do that. Oh, dear. No, come back out here. There we go. That would have been bad. Okay, so let's create our header. And as was pointed out last time, I can do pragma once. I don't care. This is fine. Sometimes, well... I guess the saying is less is more. Sometimes more is less, guys. Sometimes more is less. Let's see. I say too much. I should probably stop saying that. I'll just be silent when I'm thinking. Okay. We need to, firstly, I guess, let's kind of look at the flow that we're going to have. Did I free everything? Probably, maybe not. Probably. I think I freed everything. There shouldn't be any memory leaks. Oh, the other thing I was going to do is that's what I wanted to do. I want to try and put a union here. I don't know if I actually want to or not, because we've got I want to have like string data as well. Like I want to have these two things here. But then like I'm not good at unions. I never really used them. I can look and just kind of see. 'Cause like functionally I know how they work. It's just can I actually apply it correctly, I guess is the question. I mean, because it would be nice to just set the data like here. Like if I type def to the union, like like it's all sorts of crazy. I'm just gonna leave this. I'm gonna do some research on my own time to sort of figure that out, because I would like it to work probably like generics, and I don't think that that's gonna really do me very well because it's C. You don't necessarily have generics, and I think I'm gonna stick to C99 instead of C11, which is where generics kind of actually come up a little bit. Because Reese scared me last stream, and then I started reading a lot. But as you can tell, it actually hasn't. Okay, here we go. My dog hears other dogs barking. He's about to go off. It's okay, buddy. It's all right. Just leave it. It's fine. Okay, he's a good boy. He's a good boy. Can everybody in the chat tell him he's a good boy? Okay, so I just said again. I gotta stop being so hard on myself. I should probably stop talking out loud when I think of things. Let's do this thing here. Let's look at what we were doing. We want to be able to run as well. I think people would make different programs for this. We can. I don't want to. It's a lot of work that I don't want to do right now. So here's like our compile flow, right? Where we kind of keyword compile, and then just whatever's after that we deal with. Oh, excuse me. Similarly here, I'm going to check that second thing that we give it. Oh, that was the other thing I wanted to do. I'm going to do that after I finish this train of thought. We're going to have run. Right? And then this is going to be the flow. So we need to get some bytes. We need to get some bytes. And how I don't remember what I did in the byte buffer. Did I use uints? I did. Okay. So we need to read information. We need to read binary information, which isn't hard. It's actually easier than reading other stuff, because you can just, right? Is that, why am I like not, maybe I don't remember no, writing it's easier, but reading it isn't hard really. So we're going to go back to our util over here, and we're going to have a let's see, we'll have a read binary file. Path, we'll have a byte buffer as well. So over here, Let's create our byte buffer. And then we will read the binary file. Our path is the second argument that we will pass in, and then we will give it the binary buffer. You're a really good boy for not barking at everybody. Okay, and then when we are done, we will have a bunch of bytes to work with, and then we can pass that off to our runtime function, which will decide what to do with the bytes. Here we go. We have to implement this, and we'll save that as well. So let's pull open this right here. When reading the binary file, I guess it's a little bit simpler in that it doesn't like necessarily, you don't have to like do that. Maybe that's the only reason it's easier. I just did this yesterday, and I don't know why I can't remember exactly how to do it. Oh, we'll find a way. We'll find it. Or I guess it's more just me struggling to remember if I did it any differently than the way I'm thinking of right now. But then, like, maybe I'm thinking of this, where like writing is always easier. So here we go. We're gonna do another file. This time we're gonna read binary. We're gonna do the check again. Oh man, there's so many other things that I keep forget. Okay, I need to probably, write these down. Just really quick. Add staple to the path. That's just gonna make it a little less clunky. What else? Create common header with panic and conditional debug functions. Maybe that was it. I'm gonna add to that as I think of things. Cool. All right. So we have the same thing where we could not open, probably is the better word to use. Could not open file path. We'll just return, since we're void. We can just return from that. I think I have to do this still. I think I still have to do the seeking thing if I don't want to have. Or wait, can I just... No, I need to know the size, don't I? Well, this is going to be interesting, because this kind of just grows. So, like, what do we want to do with that, I guess, is the question. What do we want to do? Keep doing this. Keep doing that. Now that we know the size, I guess we can just do this. I mean, because I don't know. It's probably easier to just have. No, because then we'd have to. I like the functions of the byte buffer, and I want to be able to utilize those. So I'm gonna go ahead and just do this. We're gonna go like that. I don't remember what it is. Byte buffer. Ooh, I only have. Or no, yeah, we want to write. We're gonna want to do the read functions, but we'll just write into this a bunch. which is definitely probably slow, like for sure. But man, okay, we need to do something different. Because I mean, I could take like this and just say like I have a buffer now, and like a buffer of size, and then I read into the buffer size amount, and then I close the file. This is probably the best way to do it right now. We'll need to come in and like really fix this because this is probably very slow. So we can read it all in, but then we have to like one by one kind of like place it. Into the byte buffer. I mean, and that works. This will work for now. We'll read it into a byte buffer. We'll be good. Yeah, so I mean that should work. So we should have all our bytes here. We could. Well, I don't really. Yeah. We'll just do this. And we need our runtime here. Nope. I want to do the same thing that I did with the compiler, and that I have like a compiler object that I can sort of put everything, and then when it's like done, it'll come back with a status code and all that. Because I like that idea. At the same time, maybe that's not the best thing to do. Oh, well, I'll do it anyways. So yeah, we'll have this enum up here, and the runtime status. We'll have runtime success, and we'll have runtime error, where we can define more things later on. Oh my goodness. I already coded for like 8 hours today, so maybe my typing will be a bit off. Okay, so we need to have our byte buffer, which we have to include. We'll also want our byte code. That'll be pretty important. So we'll have our byte buffer here. We'll just call this code because that's really what it is. That's a better description of it. We'll have a runtime status, which is our exit status. And really, we need to have a stack. And I don't like the idea of passing around a runtime object with a stack allocated stack. And so I don't know what to do about that, because it would be really stupid to like... Yeah, maybe we don't need this. Maybe we don't need this. We don't need this. We really don't. We really don't. Okay, so let's just have... See, the thing is like consistency. I feel like I'm falling on consistency, and I don't want to. I don't want to do that. But right now we're going to just go like this. I guess, okay, if I kind of adopt the mindset of get it working and then fix it later, I think that that's probably a good idea. Even if fixing it later means overhauling things. you know, because why think about things? Why put thought? Time create. And then we can have here, we can leave the Yeah. We can do this. We can do this. Yeah. Okay. We'll do this still. Because if we're heap allocating it, I don't. If we're gonna pass it around as a pointer, that's better. You know, I mean, although I suppose that it would have been before, anyways. I'm really dumb. I don't know why I'm doing this. Here, we can do this. Okay, we can do it like we did everything else. Sorry about that. I might even change my mind again. Who knows? I think it's mad at me that I don't have anything in here. And that's because it's not a struct, it's an enum. Alright, so we can still do the runtime status. Because what we can do is we can come over here. Right, and we have to include it. Right, but then we can do runtime create. We can pass the reference to it, as well as a reference to our byte buffer. I guess this way we're kind of maintaining control of everything. You know, we don't have to call malloc a bunch of times and do we need, we'll just do start instead. How about, we'll just do start. We don't need to have a create and a start. I don't think there's really anything we need to do in between there. If we need to separate it, we can, but at the time being, we don't really need to separate it, so there's no, we won't. And here, we include the runtime, and we'll get going on this. Actually, before we get going on that, let's check here. We'll check the status. If it equals runtime error, then we should return 1, I guess. Cause I mean, if we assume that the runtime will say what the problem is, we can return 1. Otherwise, we will return, once we have that data structure in mind, once we have the stack kind of in place, then we can return here. I mean, here we should just return that. We'll kind of never get here. I'll do a -1 there if we somehow get there, because we return every other place. Although I suppose, yeah, I mean, we can have it, kind of the else there is right here. Return 1. It's not supposed to happen. Here we can return whatever that number will be that we pop off the stack, because that's how we're going to check our math. But, yeah, right now, it's fine. So let's have a stack. Should we also make a stack object? why not? Actually, yeah, we don't need to do that because we're going to have registers and stuff, and we kind of want to have those contained together. Yeah, so let's just do a uint8t stack. This will be huge, so, or we'll want it to be huge. Right now, we'll do a define stack size, and we'll just say that it's a megabyte, or a kilobyte, sorry. We will give it a kilobyte of data. We won't need more than that because we're literally pushing 2 things right now. So we have our stack. We'll want a register structure because we can actually utilize unions better here. I think. Yeah. That's about right. Okay, so we can do a register. Let's do that later. Let's just get the stack working. Let's just have a stack pointer. And it's going to grow up for now. And this can actually be unsigned, so we're going to... Or 32, because, whoa. This is going to be a 32-bit system. Because why not? Cool. So in the runtime start, we're going to take a look at the stack pointer. We'll set that to -1. We will want stack operations, and we'll do those in 32 right now. So we can do push 32, or, well, we need to do all of them. Oh, man. Okay, so we've got push 8. So what does that mean? What do we want to do? We want the runtime. Let's call that R. The data. That's about it. We can push 16 bits as well. And we can push 32 bits. This is basically going to be almost a straight copy of what we have in the byte buffer. It's a lot of bitwise operations and what have you. So literally first, it's just going to be, we're going to take the runtime. We're going to go to the stack memory. We are going to pre-increment the runtime's stack pointer, and we are going to put the data there. And we'll do what we did before, where we'll push 8. We'll give it the runtime. And, okay. We have to think about the stack because it's a first in, last out. Right? No, last in, first out, sorry. So the last one in is the first one out. This is a last in, first out data structure. Which means that when we pop everything, we're going to have to do it in reverse. So how do we want to push this, I guess? It doesn't really matter, I guess. We just have to remember to do it the reverse way when we pop it. So I'm just going to do it the way I think we did it in the byte buffer. Here we go. What's up, Reese? A global instance, host of bytecode, global variable, and a thread object. I will consider that. I would also recommend you look at the code of conduct now because I almost exclusively made that for you. You're welcome. But welcome back. Thank you for coming back. I really appreciate it. And I will take that into consideration. Actually, if anyone can backseat program, it's probably Reese, and I'll probably listen to him more. Okay, anyways, what do we got? So I'll probably do it the way that I did the other one, where I'll bit shift it over. Or no, I won't. That's wrong. And we just need to remember to do this in reverse when we're popping because of the last in, first out nature of the stack. We don't need to move that anywhere. And then we're good. Same thing here. Give it the runtime. 24, push 8. Data. And again, we did this last time where we're splitting these up into bite-sized pieces. I should go to jail for that. That was really bad. Leave that. Okay, so we should be able to push information onto the stack now, which is really great. Here, I'll put running in there. Oh, we don't have bools, do we? Crap. Too used to coding in C++. There we go. All right. So we'll have the bool. I think that they're all caps, though. So runtime running equals true. Is that not it? Is it actually just that? All right. Well, I'm not complaining. And then literally just while we are running, we will... while the runtime is running, we will execute on opcodes. So let's begin doing that. So we've loaded our binary into memory. We've created a runtime, which consists of a stack pointer, and the code that we've written. That's about it. A couple things here that are helpful to us, but the virtual machine, I guess part of this is the fact that we have our code, we have our stack, and we have a stack pointer. We will be doing registers in the future, but like I said, right now we're just going to get this to work. After we get this to work, I'll probably just create registers after we get this to work because registers will be a logical next step in the flow of creating this language. So while we are doing this, we're going to switch. I think, nope, we need to have a code index. This will be a uint32. This should be a part of the runtime. So we're going to, actually, that is a thing. It's the program instructor, is it the program counter? I forget what PC stands for. Reese, if you know what PC stands for, please let me know. But I think it is program counter. It's also called instruction pointer. It could also be IP for instruction pointer. I like PC a little bit better because IP, I mean, I guess PC has significance too, but actually I'll do IP. You know what? For consistency's sake, we're going to call it IP for instruction pointer. This will equal 0. We have to set this up here. Yes, program counter. Thank you. We will set this up here. It's not the PC, it's the IP. Ooh, did you guys hear that? That was my elbow. That was crazy. All right. So here we're going to switch on the code. Oh my gosh. We can't do it. We have to, okay. Using the byte buffer for our code is going to slow us down tremendously, I think. And we need to have something a little bit different. We might need to go and refactor a lot of this. Because, I mean, we can have functions that just take they just take a pointer and an offset, and then they just read you back however much. That doesn't really need to be in a byte buffer. So I think that what we're going to do, kind of like while we're here. Oh, nice. You know what? I'll do it. Because this is the virtual machine before the high-level language, this will have stacks and registers in the final project. Because this is just the virtual machine, so when it's actually the real language, it won't have a stack and registers. This will have the underlying virtual machine will, but the language itself won't. I guess right now I'm toying around if I continue to stream this and we continue to develop this into something that's actually good and we actually, which is the goal, then I will get more serious about it and we'll go from there. Okay, so we should just have a util function. The byte buffer is useful when we are compiling because initially we don't know how many bytes we're going to have. And so we can have a structure that kind of grows that for us. Because we know how many bytes we're going to have when we load the program, we don't need the benefit of the growing array, I guess, the vector in terms, I guess, or in correct terms. So as much as that's probably useful during compiling, when we're actually running the code, it's probably just going to be a crutch. And so we're going to have to change a lot of what we're doing. So we don't want to do this. We want to just load it straight. We want to load it straight into a buffer. So let's just do that. Let's start. Let's just have code. Oh. We have to return this. I think we have to return this. I think we're going to heap allocate it. Yay. Because we want it. We want it here. We have a function doing this. I'm just trying to think because I don't want to do a bunch of copies. I'm going to close my window because it just got a little bit more dark out. Okay. I mean, because before we actually read it, we don't know how big it is. And we'd have to copy it around probably anyways. Maybe. I guess not, but... You know what? We'll take one for the team and we'll just return from this, so we're not going to do that. Okay, so let's go change that. This is going to return that. We're going to return a bunch of uint8s. Which means we can't do this. We have to actually... I actually read the other day that you're not supposed to cast it, which confused me because I thought you were, and I know you have to in C if you want to do this, which I guess you're not supposed to do that either, but in C, I guess you're not really supposed to do that. Or maybe you are, I don't know. Sometimes I wonder, at what point is it just, a preference that people... kind of, I guess, preach as gospel, if I can put it that way. So let's just do this. You're not supposed to cast the return type of the memory allocation. I read that on Stack Overflow, so that's probably, I don't even know. To be completely honest, I have no idea. But in C, apparently, you're not supposed to do this. I know in C++ you have to, and so if you want to do the whole backwards compatible thing, I don't know. I think there's so much of people just have a way of doing things, and then they say this is the way you have to do it. There's so many old souls in programming. Okay, so we're just gonna do that. All right. So we'll get our buffer here. So we'll get our code here, and then we really just need to set it like this, and then get rid of that. I gotta turn off word fence on my test WordPress websites, or I guess the code, and then runtime start. Actually, the runtime here is just going to be, I'm going to have the code like that instead, which means we don't need the byte buffer. And we have to change this. There we go. All right, that's there. Hey, Zeke, knock it off, buddy. Hey. He's like chewing his ding dong. Okay, this is probably a better way of doing it. We'll see. Oh, cool. Nice. All right. This is probably a better way of doing it. We're going to thank ourselves later for that. And that means we can actually just add on to our util instead of this just being like a file library. We can actually have a utility. This can actually be a utility header now. Isn't that exciting? So now we can have some helpful little functions. And I'm just going to do these right now. You don't really need a... You can just take the address of a buffer, and it will return just the 8-bit value. So I guess read 16 is probably a good name. Because that's technically true, so we'll just do that. Where we have buffer and we have index. I don't know why. Reese, you infected me. Now I'm not using the platform unspecific or things. All right, then 32, and then we'll just do that right there. And then this is probably the third function we have to do bit shifting, which is probably a sign that we should do something else. Smile W, I don't know what that means. I mean, this isn't hard. We're going to assume big endian. I want to assume big endian like every time. Oh my goodness. I want to assume big endian, I think, every time because I like it. So we will do the buffer index. Right. Yeah. Bit shifted over 24. Right? Or not 24, because we're in 16. Just over 8. Right? I think that's right. That's probably right. This one's 24. This is going to be long. You're going to hate me for not doing a new line. You're going to hate me for not splitting this into multiple lines. There we go. Actually, maybe I will split that. That looks kind of ugly. Let's do that. Okay. I mean, so that works. That's fine. That's all well and good. As long as we include our util over here, we should be good to go. So in our runtime here, like I said before, we're going to be switching on the runtime code. Now I can actually just directly access the buffer. Our instruction pointer will be here. Right, and now we have a bunch of things that we can switch case. So we can case on push const. What does this do? Well, did I write the push code? Okay, I did. All right. Well, we're going to push 32. We're going to push a 32-bit number because that's how we did it. We're going to read 32 from, we'll just increment that because why not? From the runtime instruction pointer, which we will increment by 4 because that will get us to the next place we need to be. And I mean, there you go. I mean, that's it. That's all that does. So this will take the push code that we did. That'll split up the 32-bit number we get from here. Why are you whining at me? Oh, because it needs to be from the code. Actually, I don't even, since the code is passed here, I don't even really need to put this here because they're both the same thing. Might as well just do that. Come on, IntelliSense. And it's not that anymore, is it? It's the UN8 crap. Right? Did we change it? We changed it. We didn't set it here at all. Okay, never mind. We set it before. We have to leave it. Which is probably good. It's probably a good thing. I mean, there we go. That just takes the 32-bit number, that reads a 32-bit number in our code memory that's already there. Oh, for crying out loud. Is this still, no, it's not. Is it going to break? Oh, it didn't break. Return with no value. That's useful information to have. And we'll fix that, obviously, later when I have my common header that I want to have. There we go. So we can pile that first one, and we take a look at our thing here. So we'll start here at this byte, which we've defined in our bytecode as push const. Right, so that's what that is. That's the first thing that our runtime is going to see, or our virtual machine, I suppose, is going to see. It's going to see this push const. It's going to decide that now it's going to push onto our runtime stack the next 4 bytes is essentially what this does. And so the next 4 bytes are these, which evaluated as a big endian 32-bit number is 30. So we push all of this. We need to write our pop code still because we'll need to get that rolling. All right. And then it increments the instruction pointer again so that we're here now. It sees another push const. It will push 12, which is what this evaluates to as a big Endian 32-bit number. We will have 8 bytes on our stack, but we'll technically have 2 numbers. We'll have 2 32-bit numbers. That add will pop. It's going to pop off. It's going to pop off the last 2 32-bit numbers on the stack, which we already established are 30 and 12. Add them together and then push that result back onto the stack. Halt, what we're going to do with halt is we're going to have it return the last value that's on the stack. It's going to pop a 32-bit number off the stack, and it's going to... it could pop the last 8-bit number off the stack because we don't... Or no, we will. Wait, no, we won't. It could pop the last 8-bit number off because, if you'll remember, we're pushing them in order. So this will be this IE will be the last byte on the stack when we push this. Thus, whatever result that we put up there, because when we return from here, return codes have to be between like 0 and 255. Because of the way that we're pushing these, we could just pop the last 8 bytes off, or 8 bits off, the last byte, because that will just be whatever that is, which will be 42, which I don't remember what that is, and I could add this really quick in my head. Like 22A, maybe, I think is what it is. We could just get the last byte, and that will do the same thing. So maybe we'll do that. I think that would be good. But regardless, one of my stack functions here. Regardless, we will we'll write these because we have to. 30 int 16 pop 16 and 32 pop 32. I don't know why I got like all quiet and Liam Neeson-y about that. That wasn't a significant revelation. Oh boy. All right. Oh yeah. Okay, so this one's easy. Return the runtime. Or not the return from the stack SP, and we will decrement that, and we'll do kind of the same thing that we've done before, except because it's reversed, we're going to have to grab these before we return them. We'll say B. We'll pop 8. Right, and then A, so we have to remember to do it in reverse. And then we can return A shifted over ordered with B. Right, and that is not correct. I don't think that's right. Yes, it is. Okay. All right, we're good. We're good. Okay, had a moment there. Had a brain fart. I think we're good. We'll do the same thing here, and I don't feel like typing this out again. So, C B A return D 24 16 8, and there we go. That is our pop code, which again, it reverses what we did in our push because of the way that stacks work. We can now implement the rest of what we wanted to do. So add stack. We're going to take 2 numbers. Take A. And the order on these don't matter because add and multiplication, I don't remember what that's called, where it doesn't matter what order you have them in. We're going to have to make a decision about subtraction and division, but because we're not there yet, we won't make that decision. So just pop 32, right? Pop 32, except it's actually runtime this time. And we can push 32, A plus B. Onto the runtime. There we go. There we go. Look at that. We're creating a virtual machine. It's actually going to work. It didn't even take as long as I thought it was going to. Thank you, Clone Boo, for following me on Twitch. I don't think anybody was in here that heard me earlier. If anyone's confused about why I did that, just ask and I'll ask and you shall receive. And the last instruction that we have is our halt. And what do we want? See, it's nice to have registers because we could just put it in a register and then read that register later. I'm going to do this for now. I'm going to do this for now. This will very much not be the case. This will very much not be what we do later on. This exit is going, I'm going to make this like 1, 2, 3 because we can't possibly accidentally do that. We're going to set the runtime's exit, which is going to be like its exit code, essentially, to pop 8, which should still work, and if it doesn't, then that's fine. And I don't understand. Oh, because IntelliSense is slow. There we go. We will also, we're going to set the code to runtime success because we didn't have like an error or anything. We're going to set the running to false. Running to false, which means that this will stop, and then we should just return, and that should be it. Like that's basically everything we need to do. That that increments by 1, so we don't need to worry about add or the halt, really. This should work. This should do exactly what we want it to do. So when we come here, now that we have that thing, the exit will return the runtime exit. This should be it. This should be good. We should be good to go. This should be a working programming language. And it's not beefy or anything. It does like 3 things. Not state. Did I have that somewhere? Where is runtime code is my buffer, but I don't know what state you're talking about, I guess. Is it in the main here? Oh, okay. Thank you. I'm incredibly blind. Okay. Yeah, there it is. Thank you very much. Okay. All right. And the cool thing about all of this, I'm going to go ahead and clean this real quick. The cool thing, we can make these numbers like whatever we want, and it should still work. And that's like cool to like watch that. To watch, like you made that happen. So why does it have to highlight everything that I touch? So everything compiled successfully. So here we go. We're going to firstly compile our first bit of staple VM code, which will be output to this binary here. We're also going to make a disassembler, which is fun. It's fun to make a disassembler for your own thing, just to sort of like verify that when we're compiling things, they're doing what we want them to do. Because right now we have to do the XXD garbage. That's not correct. Right. And we didn't change any of this compiling code. Is my dog mad at me? I think my dog's mad at me. We don't have to change any of this compiling code. Or we didn't, and so that shouldn't matter. So we'll see. Hopefully this will work right away. That would be very nice. Could not open file because I spelled it wrong. Ready? And if we look here, it should say 42, and it doesn't. So what went wrong? Let's figure out what went wrong. Firstly, I'm just going to do this and then just cast it because if anything, that's probably what happened. So we'll just do that again. Okay, there we go. Okay, so I was wrong about the stack. You can't just take the last one. Okay, so this works now. I was wrong about the stack and taking the last byte. You can't do that. But what you can do is you can get the last 32 bytes and then just cast it because you're lazy. So this works. This functionally our programming language can just add things together. Anything you want. So we can do like 14 and 55, which should make the sex number, and we'll see if it does that. And we don't have to recompile our compiler, we just have to recompile our code. Right, and now it's a little bit different. Right, now this is a different number, and this is a slightly different number. And if we run it, and we take that return code, it's 69. Look at that. Isn't that hilarious? And really, we can do 3 different numbers. So let's do 10, 20, and 30. So this will push 3 numbers onto the stack. This add will then add 30 and 20 together and push 50 onto the stack. This add will take that 50 and the 10 from before, add that, push that onto the stack. That'll be 60. We should get 60. Well, we gotta specify that, right? This will be a little bit of a bigger binary because we have a lot of 32-bit numbers. And it's cool to like watch. You can make complex things, you know, like, and obviously when we come around to jumping and we have labels and we have more math that we can do, it's really fun to watch because you can just build things. You can just make things with just like these basic building blocks. You can have a square function. You can have an incrementer function, really. We'll have an incrementing operator, but you could make an incrementing function. You can just add 1 to something, you know. So this should work as well. Keep forgetting to do that. It should be 60, and it's 10. Why? Why? Now I have to fix this before I can go. We could GDB in, but I don't like that idea. I'm not entirely sure what happened. I'm not sure if anybody else can see it or not. But I'm a little bit confused. It doesn't have anything to do with like the parsing of it, probably. Let me look at this again. That is 10 for sure. That is 20 for sure. That's 30, and we know that because we had that before. We have 2 of these. Okay, so it's definitely not our compiler. Our compiler's working. I guess what's obnoxious is like it shouldn't break. It shouldn't be wrong. It should work in succession. So now I just want to debug it because now I'm just angry. Now I'm just mad. Oops. What? Like 7. I like LLDB better. I'm more used to that because GDB broke on Mac, and I haven't been on this machine for a terribly long time. It used to show me more code than this, but I guess that's fine. Let's go ahead and, where are we? Push, do that. So like 5 is what we want. Got another push, another that. Leave 10 is what we want. 2. I guess I'll leave that right there. Okay. Well, I'm not going to commit any of this code until it's fixed because I know there's a bug and I don't want to push it with a bug in it like this. It doesn't make sense. It doesn't make sense. It doesn't make sense at all because we did. I mean, because if you can push 2 numbers and then pop them correctly, like that should work. That shouldn't break if you have 3, and so I guess that's why I'm confused. Ooh, why? Oh no, because it does 3 times. That's right. And this should be 15. Okay, now it should be here. Okay, so we're going to, what is A? That's not right. What happened here? Or no, that's not what I want. Okay. Oh, it did do it wrong, didn't it? Would you look at that? Wait, how did that work before? Is it because they like overflowed each other or something? I'm confused. This is where the problem is here. I don't know how the answers before were giving me what I wanted. And my guess is that it had something to do with an overflow and the fact that this is only 8 bits or something like it, something crazy. That's ridiculous. Okay. Well, for one, I want to try. I'll do the just begin. What do we have before? 12, 30. Add, halt. Okay. This should work too. Did I make it? Okay. Staple. Compile. Yeah, I did that wrong on the I wrote my push code wrong. Let's see. So, let's just make sure. That will right. This is classic one from before, 42. Excellent. Okay. I'm just going to do this because I'm too lazy to go and type it all the way out. So compiling first.stvm, this one should compile fine because we didn't do anything there. Staple run out.stbc echo this 60. Okay. Somehow that's sneaky, okay? That's really sneaky. I did this wrong, which is fine. I mean, it's not fine, but that should have caught it. Something in the addition and something about binary that's going to hurt my head if I think about it for too long gave me the right result when I had 2 numbers. When I was pushing 2 numbers, somehow, or maybe it wasn't, and then just this here was doing, I don't know. Maybe 10 is just the result of some buffer overflow. I'm not sure. Or it's not a buffer overflow, of an integer overflow. Yeah, all right. So thank you, the duck, though. I appreciate your constructive criticism. I'm a weirdo for using binary ops. The 2 numbers were well, initially the 2 numbers were 30 and 12. So I could find like a binary calculator, right? Where was that one? What was it? No, yeah, here. So like 30. Holy crap. Okay. No, come on. All right. I can count. Let's do it. And 12. Well, I guess it's different though. It was. Yeah, okay. So it's 30 and 12, but then you have to switch the endianness of it and then find the binary and do the addition on the flipped endianness. No, this is C code. I do not code in Python at all. I have a little bit in the past. I don't. This is going to conclude the stream. This bit right here. I'm going to clean it. I'm on Ubuntu, and I can't tell if you're trolling me right now. I'm going to go ahead and commit this real quick. I have the terminal here. Yeah, I'm on Ubuntu. I don't have calc.exe. I'm on Linux. I could get the programmer calculator, really. Or if I have 30 in hexadecimal and then like flip it or something. I don't know what these are. Here, yeah, I'll just do this until... Yeah, 15. Another 15. Keep moving it. Okay, that's too much. Never mind. Well, yeah, just to do something simple, but I think Reese is working on it. Okay, I'm getting a massive amount of... Okay, yeah. That makes sense. Oh, use wine? I don't have wine installed. Also, that's a lot of work to get the worst calculator on the planet running. I do like the Linux calculator or the Ubuntu calculator. It is nice. I should leave it in programming mode. Yeah, okay, that makes sense. I would say there's some weird like it'll work because of something about whatever that wasn't even coherent. Yeah, that threw me off. That threw me off a lot. Thank you, Reese, for doing the math on that. You should be like my stream producer. You answer all my questions. Okay, so begin and first is kind of the same. Python is best calculator. I mean, you mean like the interface here? Like 3 plus 5? Yes, I should implement a calculator in Staple. And you know what? We will do that at a certain point. Technically, if you want to be finicky, I'm about done, Mr. Venus. Or Mrs. Venus, my bad. Yeah, we will be doing that for sure. Technically, if you want to be nitpicky, it already is a calculator because it does addition. But, you know, it's whatever. Okay, I'm going to end the stream. I told you I don't use Python. I don't know the other way of doing it. Is it just like Q thing? I don't know. Anyways, if you want to find the repository, yeah, I should implement Python in Staple. We will make a Python is Python interpreted or is it not interpreted? Because it wants to be interpreted, but I guess it has bytecode too. I don't even know. It's some hybrid monster. And I'm going to get crucified for saying that, so I'm going to go ahead and leave. Control D for every terminal program. Does that not do it? Okay, well, here, look. Or I guess Python would be the simplest. What interrupt does that do? I guess it's not a sig int. Does it just quit it gracefully? Who knows? Oops, I need to come back. Anyways, thank you everybody for coming out. Python is compiled. Okay, I thought so. It acts like it's not, and that's confusing sometimes. Okay, I will see you guys later on. Thank you everybody for coming out. Thank you for the new followers. I really appreciate it. If you would like to follow me on GitHub, that's here. If you want to follow me on Twitter, it's the same username. Yeah, y'all have a good day. I forgot that when I hit